today we're going to talk about soil science. What fun that is. And it is a lot of information. So again, I'll just start off by saying, remember when something's underlined or repeated, you're probably going to want to make note of that. Same thing with in your books. You know, when you're reading over these sections, when it's underlined, bolded, or italicized, those might want to be things you pay attention to. All right, so in this chapter, we're going to go over the soil textures and structures, porosity and water movement. We're going to talk about the soil pH, cation exchange, cation you say, well, we'll talk about that later, cation exchange capacity and buffering capacity. We're going to talk about the rhizosphere, soil organisms, and organic matter, soil moisture and absorption of essential elements, because there are some, and then gravitational water, field capacity, permanent wilting points, and the infiltration rate. These are all things you're going to have to know. So trees and soils. Well, you know, trees and soils are completely ecologically interdependent. Trees cannot survive without good soils, you know, and the soils don't do as well if there's not trees dropping leaves and helping out the little biological things moving in those soils. It's kind of, you know, they're interdependent. One needs the other. Urban development processes pretty much disrupt that ecological balance between trees and soils. You know, we grade on top of it, we strip the topsoil, we do all kinds of things in our construction process. Most trees' decline can be attributed to that soil stress that we put on them. And then the health of soil and soil-tree relationship has a major influence on tree health and performance. You know, that's the first thing you're going to look at as an arborist when you're in the field is, you know, what does the soil look like? What's been done here lately? You know, was there something chemically added to the soil that's going to change everything? You know, was it compacted? We'll talk about all that as we go along. All right, so the soil ecosystem. You have a substrate of rocks, sand, silt, clay, and organic matter that pretty much anchors roots and provides water and minerals to the trees. It's an ecosystem inhabited by insects and earthworms, nematodes, just all kinds of fun stuff, bacteria, fungi, microbes, and each of them has a specific function, and they all work together in this amazing little balance, right? You played in the dirt as kids. You remember all the stuff you found in there and constantly having to wash off your hands because your mother said so. Remember that? A parent material or underlying bedrock. So a parent material is bedrock. You know, keep that in mind. So, and you have soil characteristics, and they're determined by the geology of the soil of that parent material or that bedrock. So looking at the soil profile, you have starting at the bottom. I know it goes A, B, C, D, but really you have to start at the bottom of this to see how it really goes. You know, so at the bottom, you have that parent material, right? The main source of rock for that area. Then it becomes kind of weathered and it starts breaking down a little bit from, you know, stresses and pressures. And then it becomes a softer soil, right? So that B horizon, you get a subsoil. So that parent material has broken down even more. Well, now you're bringing in the top half of that, the organic layer, the A horizon. So where all those creatures are moving around and breaking down the leaves and wheeling through the dirt, that all kind of gets mixed into that B horizon. And those are the main areas that our trees are in. So we'll talk a little bit more about that in a second. So soil ecology varies by geographic region. It has different climates are going to determine different types of soils. Your underlying geology, what kind of parent material is there? What kind of bedrock is breaking down and making the soil? And the types of plants present is going to determine how much of that activity and how deep those layers are at the top in the A and B zone. This is a kind of a breakdown of DeKalb County in Georgia. DeKalb County has a soil survey. Most counties will have soil surveys. Those can help a lot to determine what your bedrock or parent material is and what the type of soil you're dealing with. In Georgia, we've got different zones. We've got a coastal plain, and it kind of moves in from the coast, right? Comes in, and your sandy soils mostly here. It's coming in and making more sandy soils, mixing with some stuff to make it a sort of loamy thing. As it comes on up, we're getting into more of a rock area in the Piedmont. We have some topsoil mixed in. You're picking up more clays in this Piedmont area, which is where Atlanta is. And then you got up at the very top, you're in that NWS, and that's mostly mountains, so you're dealing with a lot of rocky soils up there, just to give you an idea. Okay, so soil development and composition. Well, obviously, we just said it's made from bedrock, right? Sediment is deposited along waterways of that parent material that's broken down. And by volume, ideal soil should be composed of 45% mineral solids. You know, mineral solids would be sand, silt, and clay that came from that parent material. So 45% of mineral solids. 5% of organic matter, including the organisms themselves, as little worms and nematodes and all those things we talked about. You're coming in from the coastal plain area with the sandy mix here of soils. As it mixes in, you're getting more of a loam starting. And then as you get up to that Piedmont region, there you're, into a good loamy clay mix. Getting a lot more clays in the Piedmont area, which is where Atlanta is. And then up towards the very top in the NWS there, we're starting to get some rocks, lime, and things like that. So anyway, that's what I was talking about. And this is the the DeKalb County Soil Survey. And like I said, most counties will have that. So going on from there. All right, and this is where I was. I apologize for that. So soil development and composition comes from bedrock. It's sediment deposited along waterways by volume. Ideal soil, again, is 45% mineral solids, sand, silt, and clay that come from that parent material or bedrock. 5% organic matter, including those little organisms like I talked about, and 50% pore space. And the pore space is either going to be filled with air or water. And those are crucial. So let's talk about your soil horizons. All right. So over time, like we talked about, you get those A, B, C, D, those different soil horizons form. And they create the visible layers of soil. If you've ever been on a site where they've cut down into the soil, you can actually see these layers form. Now here in our area, we're not going to have as big of a topsoil or A layer like you're seeing in this picture next to the shovel. That really deep brown rich soil is your topsoils. And in some areas, it's really, a foot or two deep, especially out in the Midwest. But here, it's very shallow. And you can see how it layers, right? It starts from the bottom pretty much, works up with broken bedrock, and then mixes down from the top through all the activity of those little creatures moving around. So the horizons develop mostly because of rainfall, leaching, heating and cooling. I'm sure you guys have seen frost heave when you're out walking around where the ground freezes and pushes up. And then in heating and cooling, especially in clay soils, you're going to get that shrinking and cracking that we've seen in our clays here in the Piedmont. And then, so that heating and cooling moves stuff around in that soil profile. You have chemical reactions that go on, biological activities that we talked about with like the nematodes and worms and everything moving around and mixing that soil up, and the accumulation of different elements and materials in those different layers. It's really kind of neat. So a good way to remember this, your soil profile, it's a nature, it's an arrangement, a depth, and number of horizons found, right? So that's your soil profile, the nature, arrangement, depth, and number of horizons found. And they consist of 5 major horizons. The O, organic layer, that's where you got your, biological characteristics of the soil are being formed by those little guys moving around. You have the A layer, along with the O, contains most of the fine absorbing roots of trees and is extremely biologically active. You've got the B zone of accumulation, where the materials that have leached from the surface start mixing with that parent material, right? And then you have that C, that deep layer just above the bedrock, composed partially of weathered parent material that's continually forming through physical and chemical and biological weathering of the breakdown of that rock, that bedrock, right? And then R, that will be your rock layer, your parent material. So a way to remember how they go, you can say organic agitators blend crumbled rock, right? Organic agitators blend crumbled rock. The O, the A, the B, the C, the R layer in your soil profiles. That's how you can remember those 5, right? Okay. So let's look at your soil profile a little bit closer. If you are looking at how this all works together, the soil and plant sequestration of atmospheric carbon dioxide, right? So through photosynthesis, we all remember that back from high school science class, your trees basically take in CO2 and release O2. They're letting oxygen back out in. They take that CO2 and store it, store that carbon in biomass, right? So they kind of transform carbon in organic materials such as soil and sediments into humus, right? Humus, and it's a stable organic material that builds healthy soils. Humus is found, humus formation sustains soil organisms and the activity needed to support a healthy plant population, and that's usually found in that O horizon, right? in the A horizon, the soil aggregation happens in that layer. Soil organic matter and stable organo-mineral complexes form, which bind and store the carbon. And deep rooting action from like trees encourages root growth and enhances organic carbon pushed down into that subsoil. So they're storing carbon for us down there, right? And then the B horizon, you basically it's a downward movement from the top down into that C horizon where the bedrock material is breaking up. And then that solid R horizon with the bedrock at the bottom with the parent material. All right, let's talk about that fun organic layer. Woohoo! All right, so it contains organic matter, OM, as we break it down, such as leaves, twigs, bark, organisms. It's also, you'll hear it called the leaf layer or litter layer. That's where everything kind of falls down and breaks apart, right? It's extremely biologically active. It contains dead plants and animal material in various stages of decomposition. It shrinks and swells with temperature changes, right? And moisture content. It helps bind soil particles together to form larger aggregates. And when you have that mix of smaller and larger aggregates in the soil, it actually improves the soil structure. Excuse me. It serves as a food or a carbon source for soil organisms. They need it too, right? And the growth and movement of organisms through the soil, that actually improves aeration, fertility, and soil structure. So the more of those little organisms and animals and all the things moving through that soil helps break it up and create the things that trees really need. Root growth. All right. Roots grow where soil conditions are favorable. And that is no joke. When you live in the Piedmont area of Atlanta, we have a lot of clay soil here. So it has a tendency to get compacted. And trees, those little roots, the advantageous roots that go out and seek, space in the soil, water, oxygen, they're tiny like your hair fibers. And when they can't find enough stuff in the soil, well, then they go down to this little area right here that's called a broken terracotta clay pipe where the sewer used to go. And you can see people had trouble in this house, the toilets kept backing up. And this is what they found when they uncovered the whole thing. This tree that was nearby found the break in this pipe and just shot the roots right in there. I mean, let's face it, it had everything it needed: air, water, and nutrients. Ooh, but that's what the trees need. So the roots require space, organic materials, essential minerals and elements, and adequate oxygen and water. And in a broken sewer pipe, man, that's a jackpot, right? Fine absorbent roots are found in that upper 6 to 10 inches of soil. Few roots can grow deeper than 3 to 4 feet just because of the pressures. There's just not enough room for them to move through that soil. Trees can develop much deeper root systems depending on the species and the environmental conditions. But like I said, here, you're going to find them in that broken terracotta pipe. All right, the relative fineness and coarseness of the soil or inorganic material, mineral soil particles, is referred to as soil texture, okay? So the relative fineness or coarseness of inorganic mineral soil particles is referred to as soil texture. Fineness or coarseness depends on the relative proportions of sand, silt, or clay, right? Sand particles are pretty large. This little graph at the bottom, it just blows my mind every time I see this to think how small I mean, you'd think silt, that's pretty darn small, right? But then you look at clay and you really almost can't see the dot because it's so darn small. Clay's the smallest soil particle, right? So there you go. Those different types and sizes create all these little different layers in that soil texture, right? Textural classes are determined by the relative amounts of each of the three particle types. So loam is a mix of the three different particle sizes, and it's considered the ideal soil texture. It also usually contains relatively less clay. So it's a jackpot around the Piedmont area when you find that wonderful loam soil mix. All right, so this is the soil triangle. So if I were to ask you what type of soil, you have your clay on the left, your percentage of clay, so from 10 all the way up. And then on the right, you have your percentage of silt from 10 all the way down. And then at the very bottom, you have, you have sand, right? From 10 all the way over to 100. And so if I were to ask you, I'm looking for a soil type that is 30% clay. You come over and find your 30% clay. Here's your line. And then you want 20% of sand, silt. So you come over to the silt and find 20%. Here it is. And then 50% of sand. So you're coming down here, and what you have, that soil type, is a sandy clay loam. So everybody understand how that works, I hope? You're finding your percentages where the three lines come together. That's the type of soil you have, okay? It's a neat little chart. Soil texture and structure. So soil structure and texture really determines the soil's ability to hold water and provide oxygen to the roots. Oxygen to the roots, we'll get in there in a minute. It has a profound influence on the chemical and biological properties of the soil. And the texture kind of determines which species of trees will do well in a given site. You know, we probably won't see a palm growing in the conditions that we see down here for the swamp, right? So the swamp trees are kind of, you know, like the bald cypress and things like that. You know, they're used to that wet soil type and being flooded. Your live oak, wow, that's in the center. They kind of do best with, you know, a sandy loam mix. You know, that's where they are. They're coastal, so they're used to that. And of course, you know, you get these cacti type trees out in the desert, and they're used to being no water, you know, and extremely dry soils. So the soil structure is 50% of the soil is space or pores between soil particles, right? Macropores are relatively large spaces between aggregates, and they can't hold water against gravity. So once they drain through, the water drains through, they hold air, right? Micropores retain water and are the source of available water to plants between rainfall events. So you can see over on the right, you've got the slide of the macropores at the top, right, with large air-filled spaces, and the micropores with small water-filled spaces at the bottom. And then you're looking at the other two images, which is a straw and a tree with a root system. Well, okay, you say, what in the heck have you got a straw here for? Well, you know, let's talk about how trees work. And you kind of have to think of them like big straws, right? Their roots go into that soil through that micropore and through the macropores, down into the micropores, the roots wiggle down there and they suck up water. Well, anybody who's ever sucked on a straw that has, you know, the bottom closed, you can't draw air through, you're not going to get anything through that straw. So those air spaces are critical too. Gotta have water, and I gotta have air that I can use for my straw to be able to draw that water nutrient up, right? So the macropores and the micropores work together, right? The tree's gotta have both. Can't have one without the other, you know? Without macro and micropores working together, the tree is not gonna survive. And once it reaches all the water and has sucked all the water out of there, well, we'll get to that in a minute. Soil structure, all right, so chemical and physical changes to the soil organisms, activity caused, let's start this over again, shall we? Because obviously I totally flipped out on that one. soil structure. The chemical and physical changes and soil organism activity cause soil particles to be grouped or clumped together. So these clumps are soil aggregates. The size and strength and arrangement of soil aggregates form a soil structure. Root growth, freezing, thawing, and burrowing insects and other animals also can affect your soil structure. They're affecting that macropore and micropore, right? Water, what happened here? Did I go backwards? Hold on. No, I didn't. All right. Water and air in those micro and macropores, like we talked about, the size and shape of those soil aggregates and the soil texture all influence the amount of those micropores and macropores in the soil. So coarse sandy soils are dominated by macropores, right? It's going to be big pieces of sand kind of stuck together in weird angles, and it makes these big macropore spaces for air and water. Fine soils like clays, that tiny little clay particle, they're dominated by micropores, right? Because they're very small and they fit together very well. So the best conditions for plants are balanced between micro and macro, right? A well-aggregated soil structure facilitates aeration and water movement. Remember, you've got to have air in order to draw water. Bulk density. Now, bulk density is the mass or weight of dried soil per unit of undisturbed soil volume. Okay, so keep that in mind, what bulk density is. The lower bulk density equals lower weight of the soil. So there's more space, right? If it's a lower weight, it's lighter and there's more pore space. A higher bulk density equals a higher weight. So it's compacted. There's less pore space. Soil compaction increases bulk density and decreases pore space. So you see why that might be important to a tree? If all of a sudden the soil gets compacted, then I've decreased my pore space. I don't have air availability for drawing my water as a straw, that giant tree straw. And the water goes where I can't get to it, right? It gets compacted. So soil compaction is terrible for trees. All right, soil compaction. Let's talk about how terrible it is. All right, soils vary in their susceptibility to compaction based on their texture. So soil compaction destroys the soil aggregates and reduces the pore space. Soils with a high percentage of clay are much more easily compacted, right? That small fine particle gets smashed together much more quickly than a big bulky sandy soil. Soils with high moisture content are even more easily compacted. I mean, think about when you walk over a wet soil, right? You sink because you're compacting that soil below you, right? All right, compacted soils, they restrict root growth. The roots can't move through. They reduce water infiltration and availability to the tree. They limit the movement of oxygen and carbon dioxide in the root zone. It means a limited biological component of reducing large pores required by those larger organisms to move through the soil. So worms and all the things that need to move through there, they can't because there's no little space for them to get in through. And the development of a surface crust like this clay that dries out and the inhibition of water infiltration and gas exchange, all that happens with a compacted soil. It's just not good for trees. So let's look at what might not be good for trees on a compacted construction site. Now, these are some examples that I've taken over my years as a municipal arborist. You know, in this particular one, let me get up here and get my tool working here. Okay, so on this side, on this slide, you had a developer who put a soil stockpile literally up to this height on the tree. So this was all covered in clay soils, compacted soils. This was supposed to be a safe tree. So he ended up getting tickets and that kind of thing. But, you know, he said, well, I fixed it. I pulled the dirt off. Look, I took all the dirt away. Well, you can see, I mean, the damage was already done. It doesn't matter if he's taken the stockpile away. And the result is right here. it results in Quercus horizontali, dead tree, right? The compacted soils, tree can't draw any water, can't draw any nutrient, and this is the result of that compaction that happened. The tree did not survive, you know. And yeah, I can write tickets and all that kind of stuff, but ultimately I've lost a tree. Now they're having to replant, right? So up at the top, again, these were supposed to be save trees. And believe it or not, somewhere in this mess up here at the top slide was the tree protection fence. I think it was buried under this load of bricks that somebody couldn't find any other place to drop off, right? Again, this resulted in, you know, shutdowns, stop work orders, tickets, but the damage is already done and very hard to fix once it occurs. So just keep that in mind. That soil compaction is probably one of the worst things that can happen to trees aside from lack of water. Okay, come on. Excuse me. Made the mistake of having my flu shot yesterday, and it has not flu, COVID shot yesterday, and it has really gotten me today. So my apologies for that. So a way that you can test for compaction in the soil is a pretty easy tool. It's a compaction tester, right? So it's got a probe rod type thing with two handles on the top. You push it down into the soil as far as you can, and it reads how compacted the soil is. Obviously in the red zone, it's extremely compacted. Yellow, it's getting there. Green is good, and you have good loose soils. And they're relatively cheap, so I always, you know, suggest that you get yourself one of these. Comes in handy when you're doing inspections. All right, let's talk about the soil chemical properties. So pH is very important. A soil with a slightly acidic pH of 6.0 to 6.5 is generally favorable for most plants. The range goes from 0 to 14, 14 being the most alkaline soil. So the pH scale is logarithmic. Keep that word in mind. The pH scale is logarithmic. A pH of 6 is 10 times more acidic than a pH of 7. So if a pH of 6 is 10 times more acidic than a pH of 7, well, how much is a pH of 5 differing from a pH of 7? Think about that. And you need to really study this. I'm just going to say that, okay? All right. So let's move along. Just keep all that in mind with your pH. The pH scale is logarithmic, and it's 10 times more acidic between each one, right? It's logarithmic, so a pH of 6 is 10 times more acidic than a pH of 7. We'll go from there. All right, soil chemical properties. Ooh, ions. These are always so fun. Negatively charged ions are called anions. Positively charged ions are called cations. So a cat is positive that it is an ion. There's a way to remember it. A cat is positive that it's an ion. Positively charged ions, cations. Negatively charged ions are anions. Okay, so the cation exchange capacity, or CEC, is the measure of the soil's attraction, retention, and exchange of positively charged cations. The attraction between cations and soil particles minimizes leaching of positively charged ions. So you can see in the little diagram here to the side, the negative soil particles and the little positive cations. So it all has to do with minimizing leaching of positively charged ions. Okay, so ions. Sandy soils have very little electrical charge, so leaching happens more easily, right? You take a bucket of sand, you put some holes in it, you pour in water, and it runs out really quickly. Sandy soils may require more frequent applications of fertilizer due to leaching, right? Saline soils, you have an excess of soluble salts. Those aren't great either. Sodic soils, sodium is unusually high and they tend to crust, and they're associated with a higher pH. So you might need to add calcium if you're an arborist working on a tree, trying to get it helped out. Getting a soil test is crucial to see what it needs, right? So if you know it's a sodic soil after a test, then you can add calcium. Maybe what you need to do is mix that into the soil, right? Seashells, there's different mixes you can put in to bring that pH down. right? And the same thing with adding it up, right? You can add stuff to make the pH higher. So just remember, ions have to do with that electrical charge, right? So if there's less ions, it's going to happen more quickly that water runs right through it.
Hey, Kay, I do have one quick question from Marcus.
Sure.
He said, so would the answer to your question earlier be 100 times?
I believe so. If I'm doing this correctly. All right.
All right.
And I'll double check that at the end, but yeah, I believe so. So, all right, so we got that with ions. Biological properties in the soil. Let's talk about that for a minute. Nematodes. Oh, these guys are so fun. Tiny little microscopic worms, nematodes, that are all in the soil. There's 20,000 different species. Some are beneficial to trees, others are parasitic. We like the beneficial ones, not the other ones. They eat bacteria, they can eat fungi, and they are all around the fine roots. And the interesting thing I found through a very fun class on fungi is that not only are nematodes eating bacteria and fungi, but there are fungi that eat nematodes. They lay traps for them. It's really kind of cool. So it's turnabout's fair play, I guess, all under the soil, right? But that's what nematodes are. They're those tiny microscopic little worms in the soils. In the rhizosphere, you have a zone of intense biological activity near actively elongating roots. So the rhizosphere is that zone of intense biological activity near actively elongating roots. Everything's happening right there. The roots are stretching out. The little critters are moving around. It's just a huge little amazing world going on right there in that rhizosphere. All right, mycorrhizae. Mycorrhizae, fungus roots. So these are beneficial fungi. And this fungus forms a symbiotic relationship with tree roots. Means they're eating at the same table, right? They're symbiotic. They're eating at the same table. They're sharing. So the mycorrhizae roots attach to the tree root, and it helps provide water to the tree system. And in return, the tree gives a little bit of sugars and carbons to the mycorrhizae fungus. So this stuff can be really beneficial to trees who are suffering root loss or having some issue with root problems in being able to uptake water. You can, mix this stuff into the soils, they attach to the roots, and basically help the tree absorb more water and nutrient. And the tree thanks this little parasite or symbiotic symbiotic relationship by feeding the mycorrhizae with some sugars. So it's very beneficial to both. Soil moisture and plant growth. Clay soils have more total pore space and particle surface area than sandy soils. Therefore, they have a higher water holding capacity. Anyone that's here in Georgia knows if you dig a hole in our clay soils and fill it up with water, it'll stay there. It takes a long time for it to drain out. So remember that clay soils have more pore space, particle surface than sandy soils, and so they have a higher water holding capacity. A soil that is at field capacity, it is at field capacity when gravitational water is drained away. Okay, so soil that is at field capacity is when gravitational water has drained away. Capillary water is the water that remains and is stored in those little micropores, right? We talked about those. That's capillary water, water that remains and is stored in the micropores. The permanent wilting point is when a tree will not recover until water is added to the soil. So that tree has taken up all the available water in those macropores, and it can't reach the stuff that's run on passed down, right? It's kind of set where it can be, is the depth it can get to. And so once that water disappears, that's your permanent wilting point. Because I no longer have water available until you give me more water in the form of rain or sprinklers or however you're getting water to that tree. Soil moisture. So let's talk a little bit. This chart kind of helps explain your field capacity availability and your wilting point. On the blue is your permanent wilting point. And it goes from the sand at the bottom mixing through the loams to fully clay at the right. And you can see the wilting point goes up with clay, right? So it's going to be available, water availability is higher, right? And the field capacity is higher on the clay soils, and they're lower on the sandy soils because it goes deeper and runs down to a lower extent. So just take a look at that chart, kind of helps, you know, with the sand, clay, loam, which one is best. And you can see the best is that loam or silt is going to have the most available water for the tree, right? So that's what we're looking at. Now the soil moisture availability, so it kind of goes from the left to the right. The rain comes down, some of it runs off. Hopefully it infiltrates, and it's a fully saturated soil. There's water all in those micro and macropores at this point, right? But after a few days, you get some drainage, and the water table depth at the very bottom is always going to be there. They may or may not be always able to reach to that point, depending on the soil type, right? Some of that's going to disappear through evaporation and transpiration through the plant. Some of it's going to get taken up from the tree, but you're at field capacity in that middle slide. So about half of the pores are filled with water, and the other half are filled with air. Remember, I said your ideal conditions, the tree has to have a good mixture of both. I can't draw water through my straw if there's not air somewhere for me to draw it with, right? And then after a couple weeks with no rain and no sprinkling and no water, you get to that wilting point. The remaining water is so deep they can't reach it, and there's no available water left for them to draw. So that kind of explains your soil moisture availability after a rainfall event, right? And remember, that's all based on the type of soil you have as to how long that's going to last and how much field capacity there's going to be. Now, the infiltration rate, coarse textured soils like sand drain water very quickly. We talked about that earlier. Fine textured soils like clay drain very slowly. So gravel placed in the bottom of a container or planting hole will not improve drainage of clay soils. You're just setting rocks down there. It's really not going to do anything to help because it's not changing your clay soil, right? It's adding it at the bottom, so that does nothing to the soil that's above the rock. I don't know where that came from, but there you go. Truth is told. Urban soils, no organic. The urban soils, the problem that we have with these urban soils is most of them, the first thing a developer does is strips off the topsoil, right? So you have no organic layer. You have compaction because you have kids, dogs, people running around the yard, mowing the grass. And, you know, if you're like most places around here, the grass, they have put right up to like 5 foot of the tree trunk, right? So it's a disrupted soil profile, it's compacted, it has an elevated pH, right? It has an altered drainage pattern because we've changed how the water flows because we don't want it going in our basements. So, you know, we've changed how it's drained. We have subsurface barriers, you know, like driveways, streets, walkways, and we have little biological activity. So I don't know how we expect these trees to survive in these urban soils, but miracle of miracles, they manage. And don't forget, they tapped into that sewer line. So that's where they get a lot of their stuff from when they can't get it from the soil, which is kind of sad and kind of creative at the same time. All right, so let's talk about those urban conditions. Well, obviously we have problems with ivy, you know, taking over, and that ivy forms such a dense mat over the top of the tree. It gets everything the tree needs before the tree can get it, the water, it sucks out the soil nutrients. It can create, you know, an area for bugs and rats, which is good, but at the same time, it's getting the benefit of it before the tree does. So ivy's not a great thing over your trees, and eventually it will climb the tree and kill it. All in all, the tree starts to suffer and decline, right? So it makes it susceptible, more susceptible to failure. You can see on this image on the top right, you have sidewalks. We're trying to grow trees in these tiny little strips of compacted soil. To shade and provide canopy, we just have to do a better job of giving the trees space in these instances. And the same with the bottom slide. You know, now we've literally bricked and trapped this tree so that it can't really grow out and develop a good, sound, healthy root system. So it's just not a good situation for trees, and grass right up to the trunk. Again, not good. Urban soils have limited root growth. They have less aeration. They have less water infiltration because the grass and everything else is getting it first. They have decreased biological activity, like I said. They're interrupted in their nutrient cycling. So we've taken that whole process that nature is so delicately balanced and put together and just totally wiped that out. So we have a lack of those important organisms in the soil and greater fluctuations in temperature. Go take a temperature gauge out there on a sodded yard or a sidewalk or a driveway or a street, and the temperatures are through the roof, right? So we're superheating the soils on top of everything. And that's pretty much it for this point.
Well, guys, it's time to get started. I'm going to hand this over to Joan, who's going to go over exam information for you. One moment, Joan. I'm going to pop this on over for you.
Good morning, everybody. My name is Joan Scales. I'm with the Georgia Forestry Commission. And for a number of years now, we have been working with the Georgia Tree Council or the Georgia Arborist Association to host these certified arborist classes. In conjunction, myself and one of my coworkers are also certified proctors for the ISA Certified Arborist exam. So we wanted to just take a couple of minutes today to give you some information about actually applying to take the exam and the actual process that's involved in taking the exam. So, so in order to even sit for the arborist exam, you need to meet certain qualifications. So because of that, the ISA organization has created a two-step process for taking the exam. One, you apply for you show your eligibility to sit for the exam, and then once that's approved, then you can enroll to actually take the exam. So the first thing you need to do is to go onto the ISA website and create your account. It does not need to be, you do not need to be a member of ISA to create an account. You just need to go in and create an account. That is the very first step in applying to take the exam. Once you create your account, you will then start your application to show your eligibility to sit for the exam. So you would click on credentials and then apply now, and that would open your application. Once you're in the application, you need to give some information about how you're going to meet the qualification part of it. And the qualifications to sit for the ISA exam involve a combination of education and experience. So if you have a 4-year degree in something related to arboriculture, whether it be forestry, horticulture, landscape architecture, something like that, that 4-year degree and 1 year of experience will qualify you to sit for the ISA exam. And that 1 year of experience can be from any number of jobs. If you had a volunteer job during one summer where you were working on planting trees with a group, that counts towards your ISA qualifications. So it can be any number of jobs, but as long as you meet 2,080 hours of work, that will be your 1 year of experience. If you have a 2-year degree in something related to arboriculture, you need 2 years of experience. And if you do not have a degree, or you don't have a degree in something related to tree care, let's say you have a 4-year degree in history or arts or something like that, because it doesn't tie back to tree care, you would need to meet the minimum of 3 years of experience. So when you are filling out your application, it's going to ask for some letters of reference from your current or former employers. However many employers that's going to take to equal the 2,080 hours of work per year in order to qualify. So you go in, you fill out your application, submit some information, and your former supervisors will need to verify that information. Likewise, you will also need to send transcripts if you are using education as part of your qualifications. You will need to get a transcript from every school to fulfill that either 4-year or 2-year degree. If you are self-employed, you can submit letters of reference, copies of invoices, things like that to show that you were self-employed doing tree care work, and that will allow you to sit for the exam. So once you go ahead, you submit your information about your experience. You get a letter or some sort of confirmation from ISA that you have met the qualifications. You can now go in and enroll for the exam. So once your qualifications are approved, then you go in and you finish your application to sit for the exam. And of course, part of that would be paying for the exam as well. So you have 2 choices to take the exam. You can take a paper-based exam, or you can take a computer-based exam. There are advantages and disadvantages to both. The paper-based exam does not cost extra money, where the computer-based exam, you would have to pay an extra $125 fee in order to use the computer facilities. The paper-based exam, basically, it's where you have to go onto the ISA website and see where it's being offered. I will say that nowadays, with the pandemic, there are not as many paper-based exams being scheduled. For instance, even though I'm a proctor for the Certified Arborist exam, and typically proctored about 3 to 4 tests a year, I haven't proctored one in 2 years now because of the pandemic. So it's basically going to be hit or miss as to whether or not you're going to find a paper-based exam somewhere where you can easily get to take that exam. One thing with the paper-based exam, if you are going to sit for a paper-based exam, you need to complete your application, enroll, and pay for everything at least 12 business days before the date of that exam. So make sure that you are giving it enough time. The same is true with meeting your qualifications and getting your transcripts. All of that can take time. It can take weeks. So do not wait until the last minute to submit your application for the exam. You want to have all of that stuff taken care of, everything approved, everything ready to go, so that you can take the exam at your schedule. With the paper-based exam, you'll get a confirmation packet in the mail that gives you additional information about going to the testing site, as well as the exact address of the testing site. So all of that will come in the mail. The computer-based exam, you can schedule a lot more to your own convenience. You basically would need to go to the website listed right here, thepearsonview.com, and that will give you a list of any of the testing facilities that are closest to you. I know here in Georgia, a lot of our technical colleges are testing facilities as well. But that would show up on the Pearson View site website. So you can go find in a location where you can take the exam, and once you have paid for the exam and everything, you will have 90 days to actually go and schedule it. So so definitely 2 options there. As far as paying for the exam, You do not need to be a member of ISA in order to be a certified arborist, although I highly encourage it, and I'll talk a little bit more about the benefits of being an ISA member. But in order to sit for the exam, you need to pay the fee of $170 if you are an ISA and a chapter member, or $280 if you are not a member of ISA and not a member of a chapter. In addition, if you are taking the computer-based exam, it's an additional $125. So if you are not a member of ISA and you are taking the computer-based exam, it's going to cost you $405 to take the exam. So just keep that in mind as far as the cost of taking the exam. Just a little bit about how the exam is kind of broken down. This kind of gives you a percentage of the questions that come from each of the different chapters or the different areas. I know there are more chapters than there in the study guide, but this will give you some information about what to really maybe focus on. Like, let's say you are not very experienced in pruning, but pruning is 16% of the exam. You might want to really, go through that section in the study guide and maybe read some additional information to make sure that you are well versed in pruning. So just keep this in mind as you're studying for the exam, as far as the breakdown of the how the questions might break down. So the actual format of the exam, it is 200 multiple choice questions. There's no fill in the blanks. There's no anything like that. It is strictly multiple choice. Almost every question will have four possible answers. You will have 3.5 hours to take the exam, and you must achieve a passing score of 76% overall. Couple of things, to just keep in mind. If you know of somebody that's been a certified arborist for a while, what might have happened when they sat for the exam, they might have actually had a section where they actually had leaves or a branch from a tree where they physically could access that branch, and then they had to go back and identify that. They no longer do anything like that. All the tree identification questions are more generic, kind of which of these species would have a heart-shaped leaf or something like that. So there's nothing where you physically have to identify one particular tree or another. Likewise, also, as far as the passing scores, it used to be that when you took the certified arborist exam, you could fail possibly just one section of the exam and just retake that one section. Let's say you did not do well in pruning, and so maybe you didn't pass the pruning section. That is no longer the case at all anymore. If you do not get an overall grade of 76, you have to take the entire exam over again. There's no just taking one section or another. It has to be the whole exam. If you do not pass the first time, you have 1 year where you can take the test for free. But if you are taking the computer exam and you're going to take that again, every time you take that computer-based exam, you have to pay the $125 fee. That fee doesn't go to ISA, it goes to the Pearson testing facility. So it's strictly a fee for using the computer facilities. One of the major advantages of taking the computer-based exam is that you will get your score immediately. A lot of people really like that. But if you do take a paper-based exam, typically you can find out whether or not you pass the exam within, let's say, 10 to 12 days if you access your My ISA account. Lots of times the paper-based exam will be listed on there, and it'll let you know whether or not you passed or failed. but in order to find out overall how you did on each of the sections, you'll be notified by mail. That'll give you your official results will be sent by mail. Great, you've taken the exam, you've passed it, you are now a certified arborist. Your certification would be valid for 3 years. And after the 3 years, in order to continue your certification, you can do 2 things. You could either retake the entire exam again, or during the 3 years that you were a certified arborist, you accumulate 30 continuing education credits during those 3 years. I do not know of anybody that voluntarily took the ISA arborist exam again in order to meet their certification. If there is any way that you can get CEUs, highly encourage it. We'll talk about that in just a minute, but that is definitely the way to go. And basically all that means is that you spent 30 hours of training during the 3 years that you were an arborist. So that's what CEUs are all about. The recertification fee is $120 for members and $230 for non-members. So that fee is only paid once every 3 years, as opposed to if you become an ISA member, that fee is paid every year. So just to keep in mind, there are 2 different types of fees associated with being an ISA arborist. CEUs are fairly easy to get as long as you're pretty diligent about it. The Georgia Arborist Association is a perfect example. They are always offering lots of programs, both in person and virtually, where you can get some CEUs. And typically the CEUs is for every hour of training, you get 1 CEU. And it needs to be something that relates back to the different sections of the arborist exam. So you can't go to a training that's about checking the oil in your car, because that has nothing to do with arboriculture. So it needs to be something related to arboriculture. And the Georgia Arborist Association, the Georgia Tree Council, other organizations offer a lot of options for trainings, both virtually and in person. And so I highly encourage you to get on some email lists, some listservs, things like that, to find out when these trainings are available. That is one of the good things that has come about with the pandemic, is that there is a lot more virtual trainings being offered now, which make it a little bit easier for you to get your CEUs. So definitely get on some websites, become members. I highly encourage you to become a member of the Georgia Arborist Association, as well as the Georgia Tree Council, if you are in Georgia. And then if you are an ISA member, you have access to some sections on the ISA website that allow you to get CEUs online. You can read some articles and then pass a quiz, and you can get, maybe a half a CEU or a CEU. But there are options for doing that online on the ISA website if you're a member. That is one of the benefits of being an ISA member, having access to those that CEU section on their website, as well as you would get discounts on any of your certifications. If you decide to go for TRAC, the True Risk Assessment Qualification, you would get a discount on the costs of that training if you're an ISA member. Particularly if you are a commercial tree care company, there are a lot of benefits to being able to advertise that you are a certified arborist and to use the ISA logo. So that would definitely be one of the benefits of being an ISA member. There are a lot more companies, municipalities, homeowners even, that are looking for certified arborists to do work on their trees. So if you can advertise that, you might get a step up on maybe some of your competition being a member of ISA. As I mentioned, you do not need to be a ISA member to be certified, but it's highly, highly encouraged. And the membership dues every year would be $135 for the ISA. And I meant to correct this on the slide, but the Georgia Arborist Association just recently, starting January 1st, became the ISA chapter for any members in Georgia. And to be a Georgia Arborist Association, the fee is $68, not $30, as I listed on that. I apologize for that. But again, lots of benefits to being a ISA member. And that is what I have right now for the ISA exam. If you have any questions, I'd be happy to take any, or you can always email Brittany, and I'm sure she can answer most of the questions just as well as.
Awesome. Thank you so much, Joan, for all that information. We really appreciate you joining us today.
You're welcome. Good luck with the rest of the class.
Thanks. All right, guys. Well, we'll pick up here with Kay so that she can pick up with our chapter 4 on water.
Okay, chapter 4. All right. Before I get started on this chapter, we had a question come in over the break. So let me see if I can address that. The question was, with a maple tree whose roots are up in the air, can you cover those? Well, it's a tricky, kind of yes and kind of no. So I wouldn't go more than like 1 inch of extremely coarse soils over the top, or maybe just and add some mulch over the top of that. Because the whole reason a tree's roots are going to be up, and maples do it probably easier than any other species, is because they're not getting down into the soil to get that oxygen we talked about you got to have to draw. So if they can't go deep in the soil because of compactions, they're going to come above ground. Oaks do it, maples do it, and especially in these clay soils. So you don't want to cover them to the point where they can no longer draw oxygen. And whatever, like I said, 1/2 inch to 1 inch of like a topsoil, coarse topsoil over them would be about all I would do, and not compacted. Because if you compact that, then you're not allowing that air to be able to draw. Hope that answers it for you. And I know people always want to do that. Oh, we keep tripping over the root system. Well, let's just mulch it because it's really compacted. And by the way, adding about 2 inches of mulch, not up against the trunk. You want to keep it about 2 to 3 inches off the trunk of the tree. But adding about 2 inches of mulch over the drip line of the root system, at least to the drip line where water drips off those last extended leaves and branches, is going to provide better soil quality for your tree. Over 3 to 5 years, studies have found that 2 inches of mulch maintained over a tree's critical root zone allows the soil to decompact naturally. So there's that. But anyway, let's go on. I hope that answered it okay. Okay, so we're now going to go over to water management. Again, extremely crucial for trees. So in this chapter, we're going to talk about how vital is water to plants, the influence of water on plant growth and health, water uptake and transpiration and movement of water in the soils, soil characteristics, influence on soil aeration, water infiltration and water holding capacity. We talked a little bit about that before in the soils. Now we're going to get more into that. Factors that affect water loss and how plants manage loss, the importance and methods of irrigation, and then potential problems with salinity, toxins, and reclaimed water. Okay, so we're going to go over all that. So water management, the advantages of mulch. I think I just mentioned some of that. The importance of good drainage in the soil. Trees absorb water and minerals dissolved in water. Large trees can absorb hundreds of gallons of water in a day. And as much as 95% of water is transpired into the air. right? So the tree is taking it up, getting those water nutrients up to the upper leaves, through photosynthesis, it's making food and sugars, and then it releases some of that water back out, right? Up to 95% of it is released back into the atmosphere. Proper water management really is the key to a healthy tree. Irrigation might be necessary, especially in these urban planting sites, and especially new planted trees. They really need that water to be able to survive. So plant and soil water requirements. Well, key factors in water management are water requirements differ for different species, right? So certain trees need more water than others. Soil properties, the soil structure, remember we talked about that, its texture and compaction makes a difference in water requirements. Irrigation frequency and timing and the application of what technique makes a difference. Overwatering versus underwatering, we have to look at that. Water conservation, because we only have a finite amount of that wonderful clean drinking water. And then drainage. Can't drain it out, then it sits in water, and we all know what happens with a plant with too much water. You've probably done it to your houseplants. Trees are the same way. So available water or capillary water. Remember that capillary water is the available water for a tree or plant. The amount of water in the soil between field capacity and that permanent wilting line, right? That's your available water. Soil texture determines water holding capacity. Infiltration is water movement into the soil, right? Percolation is water movement within the soil. So it's moving sideways, it's moving down. Again, keep that in mind. Infiltration is water movement into the soil. Percolation is movement within the soil. So the transpirational pull is the loss of water from the leaf surface. So that leaf opens up the stomata at the top, and it's influenced by different environmental conditions like light, temperature, and humidity. But it opens that stomata, and that's when transpirational loss happens, right? The tree is releasing that water vapor, right? When water losses exceed the plant's ability to take up water from its root, well, then the plant wilts. So the water holding capacity and the effects of soil texture. Let's look at this chart for a second. So you see the sand mixture on the left, and then the loam is in the center and the silty clay loam on the side, right? So that brown area, kind of light brown, tannish brown, at the top, that's your field capacity, right? And your wilting point is below that, right? So you got the saturation happening in the top. In sand, it runs through very quickly. Remember, we talked about that. So the water in the soil depth on the left. So you've got what? 2 to 3 inches of soil in sand before it gets down to field capacity, that little bitty space, to the wilting point in red at the bottom. And with loam, remember we talked about loam is the best, right? So its available water and field capacity is much better for the tree. It's much more a broad space. And then the silty clay loam is a little bit, it's better than sand, but not as good as loam, and definitely better than some of the clays. So you have excess or gravitational water, available water, no plant stress in that point. That's your available water capacity. As it starts getting down into that darker brown area, then you have the water stress starting to happen, right? And then the red, you got no water available. It's past where the tree can get to it. So the infiltration rate, the rate at which water soaks into the soil, that's the infiltration rate, the rate at which it soaks into the soil. Soil texture, we talked about, plays a role in that infiltration rate. Sandy soils have a high infiltration rate, we talked about that, and they need frequent irrigation, right? Clay soils have that low infiltration rate, and so it has a need for less frequent irrigation. And you probably want to water slowly over a long period of time. Those drip irrigation methods are much better for the clay soils. The percolation rate, all right, the rate at which percolation occurs within the soil. And remember, it's moving through the soil and down and through, all right? Percolation rate is lower in clay soils than in sandy soils. The soil structure and bulk density really affects percolation and infiltration. And remember, we talked about that bulk density. If it's compacted and heavier, it takes longer for that water to move into it and through it, right? Makes sense. So the water movement affects and the effects of soil texture. So let's look at this little chart. So you have clay on the left, and you see the water kind of spreads out quickly and then starts to infiltrate, right, slower in the clay. Where you have an emitter popping out water over loam, it kind of goes that same width area, but it infiltrates much better, right? Goes further down into the soil. And then at the far end with the sand, you have a very narrow space because it doesn't get the chance to spread out, right? It just goes straight down, right? So your wetted zone has the greatest width below the soil surface, right? Depending on your soil type. Pretty self-explanatory, but kind of cool too. Ooh, drought. Oh, we've had our share of those. Tree species differ in their water requirements and how well they tolerate drought. Root loss, leaf abscission when the leaf breaks away, twig dieback, plant death, you know, all that's going to occur in a drought situation. Trees may shed their leaves to respond to the drought. Others become dormant. They just kind of freeze in place and shut down, right? Small leaves provide a reduced area from which water can escape through transpiration. So a tree with smaller leaves is maybe not going to have as much trouble with the drought situation. You know, some trees have an extensive and deep root system, not all of them. And again, the soil type makes a difference in how deep those roots can go, right? A turgid leaf, turgid, lovely little word, say it with me, turgid. A turgid leaf is fully hydrated, right? If not fully hydrated, the leaves then wilt, right? So as the water is released, the leaf kind of wilts and falls apart. So turgid means it's fully hydrated, it's full of water. Trees with smaller, thicker, waxier leaves tend to be a little bit more drought tolerant, right? They're not going to lose that water that quickly. And drought tolerant species for Georgia, you've got oaks with the thicker leaves, hollies, elms, and juniper, right? They're going to be our more drought tolerant species here. Drought stress, signs and symptoms. Well, when a tree gets stressed out from drought, you're going to see wilting, you're going to see yellowing of the leaf, curling at the edges. Conifers, pines, that kind of tree turns reddish or yellow or brown or purple because it's not got enough water to keep that green going. Deciduous trees may develop a scorched or brown leaf margin. They look like they burn up. You know, it's not good. Smaller leaves are produced because the tree knows, hey, I can't put out a big leaf because I got to retain this water. You know, the canopy gets really thin because it starts dropping all these extra leaves that it can no longer support, trying to save itself. So you can get an early leaf drop. And then pests. Oh, our lovely pests move in. Once the tree's in stress, it's like ringing a dinner bell. You know, the spider mites come in. You know, once those pheromones are released from the tree that say, hey, I'm in stress, it really does call the insects to it. You know, it's kind of nature's process. So let's look at a couple of drought symptoms. So the upper left is your aspen, and you'll see it starting to turn yellow from lack of water around the edge of that leaf. The red oak below it, you're seeing that scorch pattern into the veins, right, in the leaf. The pine, you're starting to lose more and more of those green needles. So it's turning brown, you know. Now, there are other things that can turn it brown. And there are other things that can make the oak look scorched and the aspen look yellow. But, you know, that's a good indicator of drought stress. The hackberry is going to wilt. You know, it just can't support itself. So the leaves start wilting. They're no longer turgid, remember? They're no longer full of water. And then the apple, it gets a scorch symptom, right? So it looks like somebody's burning up. You know, it's a good indication of stress. This is a good look at a oak tree once it's gone into that drought stress. And now let's look at what the tree is dealing with. Okay, so we got a heat load from the driveway and the sidewalk, right? In the street. So you got all this heat reflecting up on it. The roof of the house is white, which is also reflecting heat onto the tree. And then what have we put in its critical root zone? Well, I guess it's a blessing there's a little mulch there, but the rest of it is gravel, right? Which again is going to superheat those soils. So this poor tree is literally you know, thirsting to death. And you can see it's lost a major portion of its leaves. You got nothing but tip dieback going on, and it's dying from the tip in because it can no longer support those branches, right? It doesn't have enough water. Excuse me. Okay, so drought stress may not kill a tree outright. You know, it may hold on for quite some time until it gets some water again. But it makes it really susceptible. Like I said, it's ringing a dinner bell. It's putting out those chemicals that says, hey, I'm in stress. And the bugs, you know, just learn to follow that. That's what they look for, you know. Disease infestations, they can get those in following years. A tree has to have water to be able to fight off some of these naturally occurring fungus in the soil. And if it doesn't have enough water to fight that off, the funguses can then creep in, right? So drought following periods of high rainfall, wow, that can be really damaging because the wet period encourages shallow root systems, making the tree more vulnerable to desiccation, right? Stress symptoms of drought may not show up for 2 years. I mean, it can be 2 years after it was drought stress before you start seeing all these things happening to the tree. But what started it was that lack of water, right? So it's not always something you're going to see right away. Irrigation. Well, for new planted trees, they require added irrigation, a minimum for 2 years. You know, once you plant them for 2 years, you're going to have to make sure they get enough water. Because, you know, that whole planting period, you've stressed them out. You know, you've removed portions of their root system, especially if they're field dug, right? Fallen burlap. Now you've cut a percentage of that water absorbing root. So they're going to need more water. They don't have as much water to be able, roots to be able to pull that water up. Different tree species have different water requirements. Environmental factors play a role in determining your watering frequency. The temperature, the humidity, the light, the wind. You know, the wind can dry out the soils. Usually early morning or late at night are the times that you want to water because you don't have that sun and heat factor, right? It can just soak into the soil. And if it's a windy night, you still may have some problems with that. You may need to water a little longer. So you have to pay attention to your atmosphere and what's going on in the weather, right? Is it going to be windy and dry? Then, you know, you got to maybe let it soak even longer. But morning and late night before the sun comes up, that's the times to water. After planting, you know, you're really going to saturate that planting hole and let the water just slowly soak back down. And you're going to fill it up again and let it slowly soak back down. You know, you don't want to get too much water, but you want to know that the tree has had adequate water to be able to survive this planting shock that it's had, because it is a shock, right? Irrigation, you aim for the root zone. Obviously, we don't want to be watering the upper canopy. That's not going to do us any good. Watering the root collar or trunk, well, that can lead to all kinds of diseases, fungal diseases in particular. It makes the bark wet and the fungus can get in there more easily. Watering that keeps the leaf surfaces wet for extended period can also cause bacterial and fungal infestations in the upper crown, right, and on the leaves. So you really want to focus it toward the root. Here's a perfect example of sprinkler damage on palm trees. I mean, you know, the sprinklers in the center, and you can see the rot that's occurring where the water is hitting these poor trees nonstop. And apparently a really good, strong sprinkler, it's just not doing the tree any good at all, watering the bark repeatedly. So sprinkler irrigation, it's your most common method of watering. You know, getting that, you see them here, you've got the little emitter that pops and sprays around. You got the pop-up emitter in lawns. Doesn't quite spray as strong, and it lets it fall down like, you know, kind of like it's raining. That's not as bad, the top picture, than the bottom one would be. You know, they're just trying to get all these trees that are in pots wet as fast as they can. But that's not the best way to water, obviously, for a tree. Maybe good for grass, but not for trees. Drip irrigation, well, that's probably the best. It's conserving the most water because you're putting the moisture within the root zone, and it can be maintained at field capacity. It slowly drips through those little drip emitters. It minimizes soil erosion, so it's not blasting water onto the site and eroding out the dirt, which the tree needs. Remember, we talked about that. The soils the tree needs. It has a uniform distribution of water. So each plant gets its little drip emitter, right? The foliage stays dry, so you reduce that disease threat to the leaf and fungal threat. This is a good example of a drip irrigation system. So this one is pulling up water from a well over to the right, and it has a pump that runs over. It has a filter that screens the debris and stuff that may be in your well water. And then it goes into a backwash pressure valve sand filter to clean it up. And then it gets pushed out to your main line. And from there, you have little valves that run out, lines that run out to each plant. You have places where you can flush the line when it gets backed up. Sometimes, you get limes and stuff like that in the water that'll clog up the line. But, you can clean that out with that flush valve. And then each plant has its little drip emitter. So that's kind of how it works on a drip irrigation system. Then you have your portable drip irrigation systems. So on the left, you have what's one of the terms is a gator bag. That one is basically a bag with small, tiny holes in the bottom. You fill it up with water, and it allows the water to soak out slowly. The one on the right is, I think, a tree diaper, which is an interesting little thing. But it basically fills up with water, and it has the like baby diaper material inside of it, the polymers that swell with water, and then over time start to release slowly. Again, there's holes in the bottom, so the water drips through onto the plant. In my experience with these, they can work really well for newly planted trees if you don't have an irrigation system that you're going to be able to set up to do drip irrigation on your new plants. But each one of them, because it is portable, has to have water put into it. Okay, so you have to fill that gator bag regularly, like every day, every other day, depending on how hot it is and things like that, what your conditions are. And you also want to make sure that you're not setting it right up against the trunk of the tree, because again, that can trap moisture and that's bad, right? So you want to watch, you really want to check them. And the same thing for the tree diaper on the right. You're going to have water. Once it shrinks back down, it's not going to pick up water when it rains. And remember, when it rains, that area where the bags are or the diaper is not going to get water because it sheets off and goes around it, which can be good. I mean, that can encourage the roots to move out, but that's going to take time. So you really have to keep these things full. Just putting them on is not going to work unless you're going to fill them up. That's all I'm going to say. Okay. So minimum irrigation to maintain plants in periods of drought. Because here's the other thing with watering. If you're watering a plant regularly every week or every day, the plant becomes dependent on knowing that that water's there, right? So you don't want to overdo it. You just want to kind of do it to help them out through a period of stress. Like if there's a drought, you may want to water if you haven't had rain in 2 weeks, right? You may want to water if you've just planted the tree to keep it healthy enough and survive and get out enough root system and get over that stress. But you wouldn't want to do it for the rest of its life, because then when the day comes that you stop watering it, it's going to die. It's like, oh, I'm not getting my water. I don't know how to survive. I don't know what to do. So you have to think of that too. Anyway, so we want to do irrigation to maintain them when they need it, right? Use drought tolerant landscaping. There's a thing called xeriscaping, which picks drought tolerant species for an area. And there are natives in each area that do this job of xeriscaping. They can come in and learn how to hold themselves up with less water, right? Group plants with similar water requirements in the same hydro zone. So wherever you set that sprinkler or that pop-up emitter or that drip irrigation, you kind of want plants that are going to require the same amount of water in each zone. And then understand that plant's water budget. How much water does it need to be able to do evapotranspiration and keep itself healthy? To figure out how much water there is in the soil, you can set in tensiometers. They figure out how much soil moisture there is. And you can base that soil water need and the tree's water need on the tensiometer soil moisture content. So by that way, you can figure out the application rates, how often you need to sprinkle, how often you need to have that drip emitter running, how well the water moves into the soil, its infiltration rate, and then its irrigation system's efficiency, right? So it's checking to make sure the system you put in place is giving it the water it needs, right? So evapotranspiration. Well, that's basically moisture lost by the evaporation of the soil, moisture lost by evaporation of the soil's water and transpiration of the plant. That's the whole evapotranspiration deal. So you can look at the example here of the water cycle. So you have evaporation happening, off the sea. There's evaporation that happens in runoff from streams. And then there's transpiration that we talked about where the tree is actually releasing that water vapor. It all starts to condense up in the top, and then it goes over and forms clouds, and then it rains. So it's this cycle of water constantly moving, right? Moving in a giant circle, if you want to think of it that way. It rains into the ground, it goes into the sea, or it runs off into a stream. Some of it's taken up by plants, and then it evaporates into the cloud, and we start all over again, right? That's our water cycle. Recycled water, it can be high in salts, as well as other chemicals, which can really raise the soil pH and increase soil salinity. So irrigation water can be taken from landscape retention ponds, and those have really high levels of sodium. I mean, they're putting all that stuff on the yards, and it's all running off into the pond. And the roads, Lord help you if you're up north, where they're putting all the salt on the road, or like we did this weekend from the whoopee snow event we had. Yay, Atlanta. And I just have to say, no, there was no bread or milk at the store. So there you go. That's kind of a thing here in the South. Anyway, but all those salts get washed into the detention system, right? So if you're using water out of a detention system, you've got all that to deal with. So really, it has to be cleaned up. Successfully using recycled water really depends on the soil type, the water quality, and the sensitivity of your plant. And good drainage is essential, especially when you have these clay soils. Remember we talked about they just get saturated and hold water. It's not good. So too much sodium, too much salts, especially from parking lot runoff, it results in leaf scorch. And it's not pretty. So trees can't handle all that sodium. So what is this, class? And if you said sprinkler damage, you're correct. Yes, that's sprinkler damage on oaks. It's kind of the reverse of the palms. You notice the palms turn red where it's being hit with water and gray up above. Reverse that. Gray at the bottom where it's been hit by water, red up above, and this one, it's the opposite, right? But it's sprinkler damage. It's not pretty. Okay, so do not underestimate the power of mulch. Mulch. It can do a lot of good as long as it's not overdone. It conserves water in the soils. It minimizes weed competition for water. It reduces soil erosion, keeps that from happening until the tree has enough, roots up near the top to keep the soils from moving. It can improve soil aeration. The little microbes and everything in the soil love being under that little layer of mulch. It can keep the soil cooler in the summer and warmer in the winter. That's a good thing for your tree. And it creates this nice little manicured look. The only thing I can add to this is caution on how much mulch you use, because too much mulch is a bad thing. And the type of mulch makes a difference too. For example, 2 inches of hardwood mulch, perfect. 2 inches of pine straw, not so much. Pine straw breaks down quicker. So really, if you're using pine straw, you want to go with 5 to 6 inches and not fluffed. That's how these landscapers make money. They're fluffing that pine straw so that it looks all full and thick. But when you push it down, it's like an inch, maybe, if that. So you really want to get 5 to 6 inches of unfluffed pine straw to equal that 2-inch layer of hardwood mulch, if that makes sense. Okay, I'll get off my mulch soapbox. All right, mulching. So like I said, you can apply a 3-inch thick layer of organic mulch at least an 8-foot diameter circle from the trunk. Apply a thinner 1-inch layer of mulch over the root ball if necessary. But like I said, keep the mulch away from the trunk and avoid the dreaded mulch volcano. Yeah, those are bad things. Too much mulch right up against the trunk results in Quercus horizontali. That's right, over they go. And you can see that the rot just occurred right where that mulch was just piled up against the trunk. can't say enough how bad overmulching is. As much as I can say, you know, doing it right is great for the tree, doing it wrong is bad for the tree. All right, anti-transpirants. Now they're fun and they have their place. It's a chemical sprayed on leaves to reduce transpiration. So it keeps the tree from losing all that extra moisture. It forms kind of a thin coating over the leaf cuticle, and it's used during stress periods or drought conditions. A lot of times, if you're transplanting these larger trees to a site, your arborist may recommend doing one of these anti-transpirants to keep it from losing too much moisture, because it's going to be, you know, an issue while it's in stress. You want it to keep as much moisture as it can. The problem is it can be phytotoxic, which is what? It's poisonous. Phytotoxic is poisonous to plants, right? So it can poison some species. So you really have to do your research and see, can whatever tree that you're proposing to use this on, can it handle it? And that's your job as an arborist, to try and figure that out, right? Just keep that in mind. Phytotoxic is poisonous to some species, or all species. If it's phytotoxic, it's poisonous to plants and trees. Flooding, well, too much water is too much of a good thing, right? Well, you get a lack of oxygen in the soil. It suffocates the roots. It creates an anaerobic condition. It creates mineral toxicities. Fermentation of the root cells. Hey, fermentation is great in beer and wine, not for your trees, okay? Prolonged flooding can lead to decay and, like I said, fermentation of roots, not good. Flood tolerant species, we have them in Georgia. Sweet gum, you know, horrible next to your driveway where it's putting out all those little sticky balls that you slip and trip on. But it's great in an area where you get a lot of water in the yard, right? Willow tree, green ash, bald cypress, all those are flood tolerant. Now that doesn't mean they can stay submerged indefinitely, but they can handle a certain amount of flooding as long as it dries out again, because if not, the above things are going to happen, right? Photosynthesis basically stops a few hours after flooded conditions. Trees can't keep doing what they're doing if they can't draw and work. Transpiration slows down. They can't get rid of the water fast enough, right? It's just being replaced. Root loss occurs within days. The roots start dying. Trees become prone to toppling, right? It's because the roots are mush. They're not working anymore. You get a right wind event, and over goes the tree. Eventually, under flooded conditions, most tree species will die. There are very few that can survive that. Drainage. Now, on construction and land development sites, your stormwater runoff is increased due to the increased impervious site from the development, right? Your driveway, your compacted soils, your streets, all that stuff is going to increase that runoff. It adjusts the grade to allow drainage. So they don't want the water flowing to the house. They want it to flow away from the house. So they may change where the water went originally. They're going to change the drainage pattern that those trees were used to. Sites with poor drainage, you should probably think about having them install drainage tiles, right? Placed about every 3 feet below the soil surface, above any hard pan. It's kind of going to help drain that excess water off that it never had that water there before. Wrapping drain tiles in geotextile fabric can help prevent soil penetration, because once a pipe gets full of soil, it's not going to work anymore, right? So that geotextile fabric wraps around the pipe and keeps the soil from infiltrating into the pipe and blocking it up, right? So there's things you can do to help drain that soil if you've had to create an area where you now have water running to a tree that it didn't have that kind of water running to it before. Compaction, poor drainage, low oxygen, not good for plants. And that basically describes many urban soils. They're compacted, they have poor drainage. Many trees die or grow really poorly because the roots need oxygen to grow, right? They need to be able to move through, and like we talked about, without oxygen, I can't draw, right? I can't get the water up there. We do want to plant wet tolerant tree species in an area that's going to stay wet. Do plant small or medium-sized trees. They're going to tend to do better than these bigger trees in an area that's wet. Do not choose trees with aggressive root systems if your soils, are compacted, because they're not going to be able to grow out. And bad things are going to happen when that happens. So it's all about looking at your soils, looking at what's there, looking how much water capacity it has, and choosing the plant that best fits that spot. And I think that's it for this chapter.
Yeah, awesome.
Okay, so without further ado, let's dive into chapter 6, which is tree selection. All right. Hello, computer. Okay, so tree selection. We're looking at the benefits of a tree, the site characteristics when we're planting it, the tree characteristics, what's it going to do, what's its shape, does it flower, all those kind of things, and the selection of planting stock. Let's talk about some of that stuff. Okay, so important questions to consider. What is the purpose of this tree? Is it going to shade stuff? Is it just going to be a windscreen? What's it going to do? What are the functional goals of tree planting? So what's your overall goal? What's your functional goal for this tree planting? What are the characteristics of the planting site? What's it look like? What's the soil type? And what are the characteristics of that tree? Those are all things that you have to consider before you plant a tree, right? So matching the tree and the site will get, you want to pick the best benefits of the trees to match your site and give you the best tree possible. So is it going to provide shade? Is it going to provide aesthetics in your landscape, a beautiful flowering something maybe? Is it going to improve air quality? Probably. Is it going to reduce stormwater runoff and improve water quality? Maybe different trees that might do better at that. Is it going to create a wildlife habitat? Hadn't seen a tree planted yet that won't. Maybe not the ones you want, but that's what it's going to do. Is it mostly, going to reduce noise levels? Then you might want something with evergreen possibly, as opposed to something that's going to drop its leaves, right? Provide screening and privacy. Again, these are all things that you're going to have to take into consideration, before you decide what tree am I going to plant there. So in trying to match your tree and site, your tree characteristics are really important. How is its growth habitat? What's its form? If it's up against a building, do you really want something with a spreading giant canopy? Probably not. You're more than likely going to be looking at something more in the columnar version, right? What's its mature size? Will it fit in the space? What are its attributes? What are its assets? What are its liabilities? Trees have liabilities? Well, yes, they do. They also have plenty of assets. We'll talk about that. Pest resistance. Is it going to be susceptible to a pest that's been hitting all the trees in your area? Drought tolerance. Is it going to get enough water where it is? Maybe I need to pick a species that doesn't need as much water. What is its light requirement? Is it going to be a tree that needs full sun, or an understory tree that can handle a certain amount of shade every day? These are all things I got to think about. So matching my tree and my site, your adaptability, right? The genetic adaptability, and I'm tripping over my tongue again. The genetic ability to adjust to different environmental conditions. That's adaptability, your general ability to adapt or adjust to different environmental conditions. Acclimatation is the process by which trees adjust to a local environment. So acclimation, as I'm obviously still not with it from the effects of the booster shot, acclimation is a process by which the trees adjust to the local environment. Adaptability is the genetic ability to adjust to different environmental conditions. Hopefully I made that clear. All right, so your site analysis. Well, let's talk about what is there right now. What is there? And what's going to be there? Are they going to build a new house? Is it going to maybe be a pool somewhere? Are we going to have to knock down something and put in a drainage system? What's below the ground? Is there a drainage system already there? Is there a sewer line? Is there concrete because they pushed this over the top of an existing concrete patio? Those are all things you're going to need to know. So what's below the ground? How much rooting space is available for this tree? Will it be enough for this particular species that I'm thinking about to survive? Above ground, what's above the tree? I mean, are you trying to plant an oak tree underneath the power line? We know this doesn't go well, right? So it has to have room above ground as well. What's your local environment? Is it conducive to the trees? I mean, is this an area that's going to get a lot of foot traffic? That might not be so good, you know, all that compacted soil. Urban factors, again, all that compacted soil. Your maintenance requirements. How much is this tree going to get help? You know, and what all is it going to really need? Is it a high maintenance tree or a low maintenance tree? And yes, trees can be like people. Some are high maintenance, some are not. So you really got to study up on what your species is. So below the ground, let's talk a little bit about that. Doing a soils test, right? Pulling a chunk out of the soil like this probe is doing to try and see what we actually have below the soil. What's its texture? What's its compaction rate? Is it really wet soils? Does it drain adequately? What's its fertility and pH like? The temperature, the contamination. Was this an old, you know, septic field? Was it an old dump site for a gas station that was torn down a while back? All those things help in trying to figure out, will this tree survive here? Rooting space, again, how much of this area can the tree actually move into as it starts to mature? You know, they look great when they're little. River birches in our area is a prime example. People plant these little river birch trees because they look so cute with the exfoliating bark and these lovely green leaves that turn a nice color. And what happens? They didn't look up to see, because this thing is going to get 80, has the max to get 80 feet tall, right? And really becomes this huge tree. Did they give it enough space? Around here, not usually. So your rooting space, your underground utilities. Oh, there's a big one to think about. Are there sewer lines? Are there underground electric lines? We have gas lines that are buried. All those you've got to really take into consideration. And before you dig any hole, you really should be calling to have the utilities marked so you don't run into those bad issues with utilities. I've seen enough of that happen. So you're looking at what's there, your site analysis. Let's talk about your rooting space. These trees planted in these tiny little grass strips, they grow for a while, 20, 30 years, and then it's Quercus horizontal line. They're laying over on their sides. You know, there's just not enough space for them to be able to put out a deep enough structural root system to hold themselves up in these storms. And, you know, let's talk about this one down here. Okay, so we've added a paving system as opposed to pavement. And then we've made sure that the tree is going to be not compacted anymore than the paving system we put in. We fenced it in just for good measure. All these are not great for tree growth and maturity, continued growth. You've got to have enough roots to support the entire tree as it matures. So they're all things to think about. Above ground, like I talked about, utility lines. You can create tree monsters, like this one on the left that's eating the power line. That's what they end up looking like. Is this a great formation for a tree? Well, obviously not. You know, first good ice storm in the area, the tree's going to split. You know, it's been pruned for failure, basically. And the one on the right, if your idea is to light the parking lot, having the tree that close to the light fixture is probably not a good idea. Not to mention that light pollution really does affect these trees. You'll watch trees near these type of parking lot lights, and on the side where the light is going to be the last part. If at all, it shows fall color. Those leaves just stay green because they keep getting the light they need. And the tree says, I don't need to drop these leaves. I'm still getting the light. Things to think about, right? So your site analysis above ground, we talk about, you're looking at power lines. This is part of the schematic, I think, that came from Right Trees, Right Place, or they use it in Right Trees, Right Place for the power company. So you're looking at trees around the house, right? You need root space, so tall trees, you know, you're looking at your pines, your oaks, your yellow poplar, your maple. They're going to get to a height of, you know, 40 plus feet, you know, going into 80 feet. You're looking at your medium trees. In that zone, you can plant mediums of up to 40 feet in height. Flowering cherry, red cedar, saucer magnolias, lacebark elms, things like that. Then you have your small trees, perfect for spaces like under power lines. Dogwoods, crabapple, Japanese red maple, red buds, smaller trees that are not going to get that high, right? They're 25 feet or less. And you really don't want to plant anything closer than 10 feet to any power pole. It's just a good idea not to be closer than 10 feet off the power pole and 10 feet off of the lines themselves and the little transformers that sit out to the sides. Because they're just going to prune it to death and the tree's not going to survive well anyway. So site analysis above ground, look at what your tree's going to grow into and what its potential is before you can put it in the ground. Local environment, let's talk about that. So you have environmental factors that are going to affect your tree. Like I talked about, the light exposure, how much light it's going to get. Temperature extremes, good grief, the glare off the pavement, the heat load off the street. If it's a reflecting, roof, it's going to get heat bounced off of that. If it's a white painted siding, it's going to have heat bounced off of that. So your temperature extremes, can the tree handle that? How much precipitation are we going to get? How much rain do we anticipate in this area? Wind patterns. Is this something that's going to be constantly hit with a southerly flow of wind? Is it air quality that you want to help in the site? What's the air quality like? Is it totally polluted? Is it going to get enough carbon, CO2, that kind of things? I'm sure it will, but you never know. You just have to think about all this stuff. And the microclimate that you're putting the tree into, because around that house is its own microclimate. You have urban things that you have to think of when you're an urban forest, right? You have paved areas, you have structures to deal with, you have overhead wires and lights and security cameras, underground utilities, all these different regulations for where you can plant trees and where they can be, power companies, first one that pops into my head. Vandalism, you have how many people are you going to have coming up on this tree, right? Hey, I want that branch. I want to take home to my kids. Snap, whatever. Kids playing with trees. Oh, then there's the old carving thing. So you're looking at your design criteria. What's going to be in that area? What's going to be around the tree? What is it going to have to deal with? So like around these golf courses, one too many sips out of that pocket flask, and then you got to worry about some knucklehead driving into a palm tree because he can't see straight anymore. Guardrails, golly, they put that guardrail in after the fact, and that tree just grew right around it. Is this a good recipe for this tree's continued growth? No. Kids with pocket knives. Oh, we've all seen that in the South. Any old beech tree, they're going to be writing on it. And is that great for the tree? No, it's not. And then the sidewalk. Did they really plan this one out well, do you think? Looks to me we have a bit of lifting. And we know where this is going to end up, right? Oh, we've got to fix the sidewalk, or it's going to be, windstorm. I can't hold myself up anymore. Quercus horizontal line. Boom. So all these things we really have to consider. What's going to be there? What is there? How big is the tree going to get? So your tree and site considerations, design criteria. Design criteria are based on the landscape functions the tree will serve, right? So you're looking at the engineering and the architecture, routing of traffic, camouflage. Is it going to hide the power box? Climate modification. Are we planting this tree to get some shade, so that we're reducing that heat island? Aesthetics. Signage. Is this tree going to grow up and block the sign that we paid all this money to put here? And then what's going to happen. The client's going to cut it down, right? So think about all those things in advance before you decide what tree is going in there. All the design criteria that have to be thought about. So your maintenance requirements. There's another one. How am I going to get this tree enough water? Is there going to be irrigation? Whereas tree in the island, that's great, but that's an awful lot of heat load, right? And am I going to be able to get it watered when it needs it? Pruning. Am I going to be able to prune this tree enough to keep it off the building? Well, maybe not. So I want to pick something more columnar than spreading, like I talked about. Fertilization. What's that soil makeup? Is this something that we're going to soil test, or are we going to set it up originally with the soils that it may need, like using the silval cells or structural soil containers with good soils already in there that the tree can expand into under that parking lot? Pest control. How are we going to keep the pests down? Cleanup. Is this a messy tree? I mean, is it going to be dropping like the American sycamore, which I love, but those those little balls that it drops full of the stuff to get all over the cars. The sweet gums, let's not even talk about that next to a parking lot. People are slipping and tripping on the little spiky balls. So you really have to look at how much it's going to put out, because if you're planting a tree in the wrong place, your client's probably going to remove it later on. You know, they're not going to want to keep it. So it's your job as the arborist to figure all this out. What's going to do the best where you're putting it. Your tree's attributes or its assets, its function. Like I said, what's it going to do? How big will it really get? Its mature size, its form, columnar, spreading, rounded. How long will it live? Is it a short-lived tree or a long-lived tree? Ornamental traits. Does it have that beautiful exfoliating bark like the river birch? You know, your canopy density. How much canopy is that tree really going to give you? Deciduous versus evergreen. Do you want something that's going to drop leaves? Do you want something that's going to stay green to shade and to block? Maybe it's a screen. Maybe you don't want deciduous in that instance. Its growth rate. Is this thing going to grow really fast, or is it going to take it years and years to get big before we have to worry about it? Its growth habitat. Branching patterns. It's going to put out multiple branches. They're going to need to be pruned back all the time. And is it a weak wooded tree? That's not necessarily something you would have put in a parking lot. A tree that's going to self-limb may not be such a good idea in a parking lot, you think? And yet we see that all the time. So wood strength, another thing to think about as an arborist. So let's talk about some of those tree growth forms. So like I talked about, you have the rounded tops, you have spreading, you know, you think more like those live oaks that spread out. When we had American chestnuts, same kind of thing, beautiful spreading crown. Pyramid shaped, yeah, you're talking about your evergreens, you know. Oval, you know, different types of poplar and things like that. Conical, you know, even tighter little evergreen trees. Leyland cypress comes to mind. Vase-shaped trees. A lot of crepe myrtles have this beautiful vase shape. May really do well in the parking lot. That columnar I was talking about, where, yeah, it's an oak, but it's going to stay dense and tight, and it's going to grow right up near that building, and it's not going to spread out too much, and that may be something we want to look at. Open, you know, it's kind of got open areas which it'll sway and move. Weeping willows, beautiful form. Probably not something you want in a parking lot, you know. Again, it's going to need a little bit more water maybe. But you're going to look at all that in your tree forms. And this irregular shape, which can be really kind of a focal point, kind of cool thing in the landscape. So you're taking that all into consideration when you're making these decisions. So liabilities, trees have them too. Remember I talked about that. So you may have berries that stain the roof, or stain the cars, or stain your clothes if they're dropping that stuff, right? Plus it's inviting more birds if there's fruit and berry in the tree, right? So that may be maybe not something you want so much in a parking lot. No, I don't think so. Got to wash the car more often. It's probably good for car washes, maybe not good for your client. How does that root system go? I mean, is this going to be a tree like, we all know maples are prone to put their roots up high. So is that something we're going to want near a parking lot? Probably not. You know, a lot of people do it because red maple is so tolerant of the heat loads, but you know, you've got to give it room to expand. If you're going to put it there, you might not want to put it in these tight little spaces. Put it off the parking lot so that it can expand out, and not in an area where you're going to have people walking over it, obviously. Oh gosh, the thorns, right? The hawthorn springs to mind. Gorgeous tree, but is that something you want near a playground? Probably not, you know. And the berries, again, you know, is it going to cause more problems in the long run as this tree drops this fruit? So it's all things to think about. It may be a positive thing in certain areas. It may be a liability somewhere else. So the characteristics of trees, each one is given a hardiness zone. So trees that survive better at the tip of the Keys are not going to do so well up north, right? They're not made for that. Although as we're getting more warming coming in, you know, here in our Piedmont area, it's getting a little warmer. So, you know, the palm trees are starting to do better here. But you got to look at all that. Where is the tree supposed to survive? What's its natural condition? Wind and storm damage. Is it susceptible to real breakage easily? Is the wood weak and you're putting in an area of high wind? So look at your tree's characteristics. How much light does it need? Again, does it need full sun or is it an understory? It's not going to get much, light, so maybe an understory is better there, Pollution tolerance. Some trees can handle a certain amount of salts in the soil. Some can handle, a little bit more pollution load than others. How pest resistant is it? Or what's its susceptibility to pests, right? If it's not getting everything it needs. All these things are characteristics the trees have, which you really have to look at when choosing what tree you're going to put where. So the tree species sources, native species usually grow well in their natural range. They're used to that type of soil. They're used to the environmental conditions. They're used to the amount of water and wind load. So, a native species tends to do better in its native natural range. Introduced species that have been here for quite some time, or non-native or exotic species, they could be very successful. Like I said, the palm trees are not really native to our region of the Piedmont, but they seem to be doing better here with the, heat load that we're getting, right? Naturalized species that have been here for a long time that weren't originally from here, but they have adapted, acclimatized, and reproduce and thrive in their new setting. They may be great, or they may have invasive tendencies, which is not good. Around here, we have the mimosa and the pauina. They have really taken hold here, but they're invasive and they crowd out our natives. So it's all something to think about as to what you're going to put where, right? Natives, like I was talking about, your magnolias here in the south, your dogwoods, flowering dogwoods, the oaks, some of the maples, and the black gum, they're all native to here, and they do really well here. The black gums are a heat lover. They're actually a really good street tree. So learning your, where you are and what's your native trees helps a lot. Introduced, well, it can go good and it can go bad. We've introduced Akusa dogwood here, and it's done really well. It doesn't mind the heat load of parking lots and things like that. Tends to do very well. It has some really pretty characteristics. Ginkgo biloba is another one that does really well here. Puts out that beautiful fall color. Even eucalyptus is doing well here. It doesn't quite get as big as it does over there, but that can be good too if that's the area you're picking it for. But things that have gone bad, turned invasive, like I said, mimosa, chokecherry, Chinese tallow tree, that princess or pauina tree, not good. They've become so invasive, they crowd out our natives. Selecting trees at your nursery. Let's talk about that for a minute. You really want to select a healthy, well-balanced crown with dark green foliage, if it's a type tree that needs dark green foliage. If it's a silver, picking dark green on a silver is not going to be the same. You know what I'm saying? Make sure the tree that you're looking to buy fits the characteristic for that plant. One dominant trunk. Everybody thought, hey, those triple trunk baby river birches look so pretty. And then as they got bigger, all this codominancy happens, and we get included bark ridges, and then one trunk falls, and the next trunk falls, and if you're lucky, you're left with one at this weird angle. So one trunk. They're beautiful trees with one trunk. So a dominant trunk and evenly distributed branches, not all mangled up like somebody just went, I think I'll prune today. Okay, I'm done. And didn't really look at how that tree is supposed to look. Good stem caliper and taper. So is the tree, thicker at the bottom where it goes into the ground like it should be, or have we got these weird formations in the trunk? We're looking at the good stem taper. Healthy roots, okay, so when I go to a nursery, yeah, I'm unwrapping some to see what it looks like in there. I'm not ashamed of that. Container trees too, I want to see that they're not root bound beyond repair. You have good lateral distribution, or have we been left in the same pot and never root pruned, and now we're just running roots in circles and we're not going to survive very well. We go through a lot of stress because I'm going to have to cut all that stuff off before I plant you. No insects. No disease problems. You're going to be looking for that. You're seeing bugs all over them. Well, we might have a problem, Houston. And no giant wounds on the trunk. I mean, this is a young tree, and now you've got that wound that's going to be there forever inside the tree. Or branch injury, it's just broken off as opposed to correctly pruned. not good. These are all things you're looking for before you buy the doggone thing. Additional things to think about, your production method. Was it ball and burlap? Okay, now you've dug it out and you've cut a bunch of the roots. You have to harden it off. There's all these things to think about. Your maximum size at planting. How big is this tree going to be that you're trying to put in the ground? Your root ball condition, your root collar location. Is it buried in about 6 inches of soil? You know, you got to look at all that stuff. Caliper and height relations show. Has somebody pruned this thing up to a lion's tail where it's just got this little poof waving in the breeze and giant long trunk? Your foliage condition. What do the leaves look like? Are they starting to turn brown in places? Are they starting to turn yellow? That's all the stuff you want to look at. And your structural uniformity of that crown. Is it a nice shaped crown like in this picture on the right, or does something not quite look right there? So you have 3 types of stock trees. You have bare root that comes with no dirt on it at all usually, and covered in this gelatinous goo, if they're doing it right. That is a polymer that keeps it from drying out, because it's critical with these bare root trees that they not dry out. If those roots die from too much exposure to air and they dry out, the tree's not going to do well. It needs those fine roots to be able to take up water and nutrient, remember? Ball and burlap, like I said, center one, there you're cutting the tree out of an existing ground and wrapping it up, right? And you're severing a bunch of the root system when you do that. So you know the tree's going to go in a transplant shop. So it's going to need a certain amount of care. All of them are. And then containerize, like I said, you're going to check to see that that root is not bound and wrapped up in that container. And with all of these, except the bare root, you're going to be checking to make sure that the root collar is not buried, because that's, you know, they wrap it up and they just add soil in there to keep it compact in that ball. And same thing with containerized, and they mound up dirt over the top. So you want to clear that off back down to the root collar. And I think we're done. So hopefully, if we have any questions, they're going to be in there. And if not, then it's been fun talking to you guys today, and I guess I'll see you next time.
Awesome. Thank you so much. We will definitely see you on Thursday, and we'll be going over Chapter 9 with Rob Swanson, Support and Lighting, as well as Chapter 11, Healthcare with Rob. All right. Thanks, Kay. I appreciate your time. I hope you get to feeling better.
Thank you. I'm feeling better slowly.
Yeah, the vaccines will get you. So
they will.
Feel better, and we will see you again next week.
All right, everybody, take care.
Thanks.